Pressure control ventilation part 4. Pressure control ventilation. We must be know here clinical mechanics, waveform graphics, algorithm for management. Breathe phases overview. TLC, what you are using for in the last lectures. T mean trigger initiated by machine or patient, by machine time, by patient pressure or flow. Limit, maximum value sustained during inspiration, target pressure less than or equal 30 centimeter water. Cycle, terminate the inspiration, begin expiration time cycle via time inspiratory set 0.8 to 1.2 per second. Pressure control, pressure waves form here, even square wave, square form, or decelerating form. Decelerating form in non-homogeneous lung, it's better to distribute the air all diseased lung. In the pressure control trigger phase, in the trigger by machine, as we said before about respiratory rate, you set 15, 60 over 15, it equal 4 seconds. Every cycle we have, every 4 seconds, we have one cycle. Patient trigger minus 2 centimeter water or flow trigger 5 liter per minute or less than according to your patient effort. Limit phase and lung protection. Inspiratory pressure limit must be not exceed 30 centimeter water, protect pulmonary parenchyma from paratrauma and overdistension. Key protective targets, tidal volume target less than 8 ml, predicted body weight plateau less than 30, driving pressure less than 15 centimeter water. Lung protective strategy, volumetrauma, overdistension, overstretching of the alveoli causing by excessive tidal volume more than 8 ml per predicted body weight. Barotrauma, alveolar rupture due to high transpulmonary peak and plateau pressure more than 30 centimeter water. Adjust protocol dynamically to guaranteed deliver vital volume remain less than or equal 8 ml per predicted body weight. Pressure control, in this time you are cycling phase, you start expiration, normal inspired time from 0.8 to 1.2 per second. What time you are using short, what time you are using long. We are using long if you need oxygenation strategy. Utilize long inspiratory time in the ARDS patient, prolonged time inspiratory. Short time 0.8 to 0.95 obstructive lung strategy in COPD patient and asthma patient to allow long expiratory time to prevent dynamic hyperinflation and autopia. The primary goal in the long maximize the PF ratio, arterial oxygen over saturation oxygen in the monitor. Primary goal, prevent the air trapping in the short inspiratory. Breathe types in here, no effort in the mandatory, trigger here machine, cycle machine, assist breathe, patient effort, trigger by patient, pressure or flow, cycling by machine. The post-mandatory and assisted breathe time, cycled and pressure limited pressure control. Here curve for assist and the other curve for mandatory. Pressurization simple setting, trigger initiation set respiratory rate 15 beats per minute, or by patient pressure trigger -2 or flow trigger 5 liter per minute, and then set your limits, pressure target 15 centimeter water, and termination by inspiratory time 0.8 and 1.2 per second. Ventilation interaction or ventilation, this patient like simulation. There is area for set by physician, pressure control 15, respiratory 20, and time inspiratory 1, and beep here 5, and FI2 is a 40%. In this area of the curves, this pressure to time, flow to time, and volume to time. Important curve here in the pressure, the flow to time. Must be in inspiration to reach to the baseline and expiration to reach into the baseline. Here the monitor, peak 20 centimeter water, tidal volume here 480 ml, and measure respiratory 20 per minute. Flow and tidal volume principles. The core equation must be, you set driving pressure equal 15 centimeter water, volume delivery formula, deliver tidal volume equal flow multiply time. This is your curve. Clinical rules: if inspiratory time is truncated too short, delivered tidal volume will drop significantly. Must be patient start inspiration and then decelerating flow until to reach to the baseline. And here pause and start expiration. Inspiratory flow baseline criteria. And you have three cases. In the case one, inspiratory flow reaches to the baseline. You set here the pressure 15 and time inspiratory 1 second. In this time, the tidal volume delivered to the patient 480 and maybe reach to around 2/3 from this 1 second, and the remaining of the second there is pause static flow. This patient inspiratory flow reached to the baseline without pause in 15 and time inspiratory 0.8. In this time deliver the same 480, but after inspiration direct will start expiration. In the case 3, inspiratory flow doesn't reach to the baseline. You give 15 and you decrease the time inspiratory. The delivered tidal volume in this time 380 decreased by 100 ml. In the clinical rule, inspiratory flow must be reached the baseline, guaranteed the maximum delivered tidal volume for given set pressure. That in the curve. In the case 1, you reach to the baseline and there is pause and then expiratory start. In this curve, you reach to the baseline and followed by expiratory direct. In this case, you didn't reach to the expiratory time. In this time, there is patient need to more inspiratory. So the tidal volume in this time decreased by 100 ml and you start your expiratory phase. Expiratory flow and air trapping. No air trapping, normal exhalation, expiratory flow complete return to the zero baseline prior to the next breath initiation. The total beep equals set beep if you are make expiratory pause bottom. If you found total beep equals the set beep and the deliver tidal volume 48, there's no auto beep. Auto beep present air trapping. Expiratory flow failed to return to the baseline. The gas trapped inside the alveoli and built up of auto beep. The total beep equals set beep plus auto beep. Effective driving delta pressure decrease and the delivered tidal volume in this time 380. Air trapping, then auto beep will happen, then reduce delivered tidal volume. This patient, male 70 and his height 170, important height, diagnosed bilateral lung consolidation pneumonia ARDS, have 7.20 acidemia, and here BCO2 80, this means respiratory acidosis. Current ventilation state, the patient have 15 pressure and the peak 20 and the measured tidal volume 380, low from the predicted body weight respiratory 20 and time inspiratory 1. Primary goal here, increase the minute ventilation because minute ventilation equals tidal volume multiply respiratory to wash out the CO2. What's your plan? Check if there is auto beep, in this time present auto beep, increase the expiratory time by reducing time inspiratory from 1 to 0.8 and reduce respiratory rate from 20 to 18. If normal, check inspiratory flow. If inspiratory flow truncated, if the inspiratory flow doesn't reach to the baseline, increase inspiratory time to complete the volume delivery. Good increase in inspiratory pressure. What time increase pressure? If both of them, in inspiratory and expiratory flow, return to the baseline, increase the pressure control while keeping the plateau pressure less than 30. This is what I said before. BCO2 high and pH acidemia. There is auto beep, increase the time expiratory. If no auto beep and flow, if inspiratory flow not reach to the baseline, increase the time inspiratory. If all good, flow normal, increase pressure inspiratory. What your target to monitor? Tidal volume from 4 to 8 predicted body weight, plateau pressure less than 30, and the driving pressure plateau minus beep less than 15, expiratory time more than or equal 3 time constant to prevent the auto beep. Thank you.